Folks, in our previous examples, we talked about di-substituted benzenes, and we said that benzene could have more than one group. As we could imagine, this is going to probably get a little more complicated. And how do we handle this more than one group getting attached to a benzene ring? So we talked a little bit about what to do as far as OMP, yeah, you know me, or we talked about OMP. Becky, look at that ring. All right, so in this video, I'm going to revisit the benzene ring again. But this time what I'm going to do is put two groups on here, and they're going to be different. Oh, look at what I'm doing to you now. You knew this was coming. You knew that this was going to happen. So we've got a little bit more complicated example to go by. So what do we do? All right, here's the deal. What do you call this structure in the middle? Well, that's called a benzene. Okay, good. You're partly there. What do you call the Cl group? Well, Tracy, that's called chloro. Okay, well, that's good. What do you call the I group? Oh, well, Tracy, that's called the iodo group. Okay, well, that's good as well. So now you just put all the pieces together. And remember what the IUPAC rule said? The IUPAC rule said alphabetize. Okay, so that means I'm going to write chloro first, and then I'm going to write the iodo second, because C comes before I. Okay, good. Look at what we're doing. We're using IUPAC rules that we already know. Nothing yet has been new. The IUPAC rules basically tell me directions. We've not modified or changed anything here. Now, the issue, numbering. Well, the I, you're going to look at this and you're going to say, well, this is a halogen. And then you're going to look at the C and you're going to say, well, that's a halogen too. Which one has more priority over the other? They don't, because they're both halogen. Well, that's good. Your mind is at least in the right place. So in this case, they both are halogens. C comes before I. So when I go and use IUPAC to number these, this is spot 1, because C comes before I. That means that this is spot 2, and this is spot 3. That gives me the lowest number possible for them. So 1 chloro, 3 iodo, benzene. And folks, there is the IUPAC name for a di-substituted benzene where the substituents are not the same. Oh, I said it kind of fancy there, didn't I? Yeah, it's a build-up process. That's really what we're after here. So let's try another example. Here we have a benzene ring, and we have a No2 group, and let's say a Br group that's here. How do we name this? The same. Okay, so this benzene ring, well, I'll write down the word benzene. So there we go. What do you call the No2 group? Well, the No2 group is called the nitro group. What do you call the Br group? The Br group is called the bromo group. Which one comes first in alphabetical land? B or the N? The B does. So bromo and then nitro benzene. Now, both of these are not halogens. Bromine is a halogen, but nitro is not. So does that mean the rules that we used before with IUPAC that basically said, hey, if halogens are there, give it the lowest number possible, but if something else is on there, try to give it the priority over the halogen? And the answer is, no. It's not. The benzene land is actually going to break these rules down a little bit simpler for you. And it just basically says don't give anything a priority, right? I mean, if you have an NO2 group like this, we call it a nitro. If you have a Br that we call a bromo, you don't really give one priority over the other. You just stick to the alphabetizing. That's what you do. So which one comes first, the B or the N? The B comes first. So that means in the numbering of the IUPAC name, this will get spot number 1. This is spot number 2, and that would be spot number 3. So 1 bromo, 3 nitro, benzene is going to be the name of that structure. Now, don't forget about O, M, P, Becky, because we can still use those, right? So this is the O, M, there's the M. So this could be a meta, chloro, iodo, benzene. And then the second one down here at the bottom, this is where I start. There's my bromine. So this is the O, M. All right. So this is also the meta, bromo, nitro, benzene. If I don't want to use the word meta, I could also just write the letter M, and that is what that stands for. All right, so let's do another example. I think we're on a roll. I think you're feeling good about it. So why ruin it? So let's keep it going. We'll do another benzene ring. And then here, let's do a CH2, CH3. And then on this side, let's do something like a Cl. So what would this name be? Can you do it? Well, let's try it. You can maybe pause me and try it on your own and see what you get. I bet you probably won't. I know how these things work. So this ring structure, that's called benzene. I can at least start there. The CH2CH3, this is called ethyl. The Cl, this is called chloro. All right, so C comes before E. I know I'm going to have to write that into the name. So chloro is going to be written first, and then ethyl is going to be written second. And just like before, Benzene Land says, when you name them, you write them in alphabetical order, and that's really how you give the numbering. So because C comes before, that gets spot number 1. This gets spot 2, that gets spot 3, this gets spot 4. Folks, it would have gotten 4 if I went up and around as well. So we're going to have a 1 chloro, a 4 ethyl, benzene. There's the IUPAC name. Common name, I can use that too. O, M, P, Becky. All right, so there's the P. That means that this is para. So para, chloro, ethyl, benzene. If I didn't want to write the word para, I could just simply write P, chloro, ethyl, benzene. And there's your name that includes the ortho, meta, or the para. All right, let's look at another one. Here I'm going to have a ring. This ring's going to have a Cl and a CH3. So let's talk about one of these. Okay, so I'll look at the structure, and I'm going to use the rules that I've used before. There's going to be no difference here. So, okay, benzene. Am I setting you up for a trick? Oh, well, let's find out. There's benzene. This C is chloro, and the the CH3 is methyl. So C comes before M. So chloro, methyl, benzene. C came first. So this is spot number 1. And this is spot number 2. 1 chloro, 2 methyl, benzene. And you give me that as an answer, and guess what I'll do? Ding, ding, that's correct. You thought there was going to be something different there, didn't you? Yeah, I know. Sometimes I lead you up to believe something that's not really true, but not in this case. This actually worked. So 1 chloro, 2 methyl, benzene is going to be the name of this structure. However, there's another way that we can name this thing, right? And this is O. Oh, and we stopped there. Okay, so this is ortho, chloro, methyl benzene. So that works. If I don't want to write O, ortho, I can write O. And this is O-chloro methyl benzene. That works for me too. That's also a ding ding. You get it correct. But there's actually another name that this thing can go by as well. Oh, gosh. He's just adding more and more and more and more. How am I supposed to keep up with all of this? Okay, well, nothing major is going to happen. But what I want to do is I want you to go back and I want you to think about those common benzene substituents. Remember these? Toluene and phenol and aniline, benzene sulfonic acid, benzonitrile, benzoic acid, benzaldehyde, styrene, and anisole. Remember those. I told you you're going to have to remember them. You should remember those structures. It's one of the few times that you're going to see me say memorize. Well, the reason that I'm showing you this is because in this case, look at this. This benzene with a CH3 group is called a toluene, isn't it? Right there, toluene. Okay, so if I go back and take a look at this example, well, I've got a benzene that has a CH3 group on it. So is there a way that we can name this all at one time? And the answer is, of course, there is. This benzene with a CH3, we already know this is called toluene. So we can write that down as a name. And if I do that, here's the issue. If I do this, because I've included this group, this CH3 group, as part of that name, by default, this starts at carbon number 1. And that means that this is carbon number 2. So in this case, the name is going to be 2-chlorotoluene. And that is also an acceptable name for this structure. It's using a common name blended with a little bit of the IUPAC stuff. And this is perfectly okay for benzene. It's not a problem for it at all. We can do that. It's accepted. Now here's the story with toluene. In recent years, and I'm talking about just the past couple, they really have looked at these structures, and for some reason they have an issue with toluene being used in this fashion. They're okay with all the others. They're okay with using styrene that way, anisole that way, phenol that way, benzonitrile that way. They're all perfectly fine with it. But they're just not liking toluene into these names, right? And the IUPAC committee basically got together and said, I think we want to do something. Let's get rid of this rule that we said was okay for years. And then they do it. I mean, I guess they have to justify why they have to do what they do, right? So they actually are telling you not to record the name this way if you use toluene as one of those components. It's okay with all the rest of them, just not with toluene. But here's the story, folks. It's been around for years. People are using it. They will continue to use it. And if you give me this as a name, I will accept it as a proper name for that compound, right? It was a proper name when I took organic years ago, so I think it should be a proper name for you now. So we'll just keep it. And if that's what you want to report, that's what you want to report, and that's what you'll do. So I'm not going to argue with it. It was proper at one point, and all of a sudden it's not. Give me a break. All right. So let's take a look at another example. Here's a benzene ring. And then here, let's put an NH2 group. And then down here, let's put an NO2 group. Oh, okay. Now what? Well, remember those common names. Remember those common names. The NO2 group is called a nitro. And we know what that's called. This thing is called a nitro group. Not a big deal. We've seen that before. The NH2 group up here at the top, this is an amine. Now, that's just the functional group, an NH2. It's not the name of it, but it's an amine group. All right, well, that NH2 group is attached to a benzene. We have not learned how to name that. We know what to do when amine is attached to a carbon chain. We learned that back in Chemistry 251, or Go 1. Right there you go. We named and named and named, and we've drawn structures, and we said, what's a primary amine? What's a secondary amine? What's a tertiary amine? I mean, we went through a round of those types of questions. But never did we properly say how to name an NH2 on a benzene. Folks, not a problem. Guess what? This is one of the common names that you memorized. So what that means is that if I take this benzene and if I include that NH2 group in with that benzene, I can kill two birds with one stone here. I can double duty. And this was called aniline. So by writing the word aniline, kind of like toluene, I'm taking care of the benzene and the NH2 at the same time. It makes the name a little bit shorter. It makes it more compact for me. I like that. It saves me from writing stuff down. Okay, well, if I do this, then by default, that NH2 is going to get the number 1 spot because that's the way that I've named it. Then this will get number 2, then that will get number 3, and this will get number 4. So, 4 nitroaniline would be an acceptable name for that compound. I could also, instead of 4-O-M-P, Becky, I could use para nitroaniline or P nitroaniline. All of those would be an acceptable name, folks. Every single one of them. A number or the common OMP nomenclature system. All right, let's take a look at another example. This time I'll have a benzene ring. And let's put an OH here and a CH2CH3 group here. Name it. Push the pause. Test yourself. Can you do it? Okay, well, let's try. If I had to name this CH2CH3 is called an ethyl. This OH group, that OH group is an alcohol, right? But that's not the name, what it shows up with a benzene ring. We've talked about how to name alcohols on single chains all the way down, but never did we really talk about how to name an alcohol on a benzene. But this was one of the structures that you should have remembered. I can take care of that alcohol group. I can take care of it with one fell swoop. If I can think of the name that allowed me to combo that benzene ring with the OH group, then I can take care of both of those at once. And we had that name. That name was called phenol. So by naming this a phenol, I've taken care of the benzene and the OH at one time. This is spot 1 because that's the way that I've named it. And that means at spot 2, that is where my ethyl group is going to be. ETHYL. Ethyl. Well, 2-ethylphenol would be an acceptable name. This could also be called a O. Okay, so ortho, ethyl, phenol, or just simply an O, ethyl, phenol. Perfect as well. Which one do I want? I don't care. The question could be, give me a name. You just give me whatever name you want to give me as long as it's acceptable, that we've went over, that we've talked about, I'll count it right. Whichever one feels good to you. That's what this is all about. That's what organic's about. It makes you feel good. It's supposed to, at least. Now, there's one other thing I want to mention here. And this is a benzene ring that has a CH3 maybe here and maybe a CH3 group there. 2 CH3 groups. Okay. How do we name it? Well, you might look at this and you might say, oh, okay, well, this one's not a big deal. This CH3 is called a methyl. That CH3 is called a methyl. So this is a benzene. And then it doesn't really matter because they're the same. So 1, 2, 3. So 1, 3 dimethyl benzene. Ding, ding. That's correct. I give you credit for that. Not a big deal. There's another way. Oh, okay. There's another way for this. So here's spot number 1. So this is O, M. Okay, so that's meta dimethyl benzene. Ding, ding. That's correct. I give you credit for that too. Well, if you didn't want to write meta, you could also write M dimethyl benzene. Ding, ding. That's correct as well. No big deal. Or you could look at this and you could say, well, wait a minute. You just told us that I could take this benzene ring and I could include that methyl group in it, and I could kill 2 birds with 1 stone and take care of both of those at one time if I just simply use the word toluene, right? And then if I do, that would be spot number 1 because that's where I've named it. And this would also still be spot number 3. So this would be a 3-methyl toluene. Ding, ding. I give you credit for that as well. That's okay. But there's another. Oh, God. Oh, no. What is he talking about? There's another. Yeah, there's another. You know, back in the day when we talked about these benzene rings that had groups on them and I told you how to memorize them, CH3 was one of those and we called that toluene. But we just kind of stopped it there. We didn't really go on any further. It was just one substituent on a benzene ring. At no point in time did I tell you to memorize any structures that had 2 groups on a benzene ring. Here's one of them. It's very common. We see it in a lab very, very often, which is why I would like for you to know what a benzene ring is called that has 2 methyl groups on it. All right? Only when it has 2 methyl groups on it can we use this name. And this is called xylene. 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 Well, I've got to kind of tell you which xylene we have because there could be different versions. The 2 methyl groups could be side by side. That's the O. And then the methyl groups could have a 1 carbon apart from each other. That's the OM. And then the 2 carbons could have 2 carbons between each other. That's the OMP. Becky, that's the P. That's the para position. So there's different forms of xylene, and we still have to go in and tell you which type of xylene that we have. And in this case, folks, we've already said that this was the meta position. So therefore, this is the M xylene or the meta xylene if I want to write the entire word meta out. All right, so that's the only thing I want to say about this type of benzene ring. You know, it's one of those things that it is pretty common. We have a common name that's associated with it. We see it very often in a lab. There's 2 methyl groups on it, and when there's 2 methyl groups on a benzene, we give it the name xylene. Xylene. There is a ortho-xylene, the 2 methyls side by side. There's the meta-xylene, which is what you see on the screen right now. And there's a para-xylene. And that's where the methyl groups are directly across from each other. All right? So just an extra little name that we can put into there to get comfortable with and to become familiar with. All right, so here's some example problems. We'll do these 4. We'll call it a day, maybe, unless you've got other videos to watch. And we're going to look at A, B, C, and D. We want to name them. It says name the following. So it doesn't really tell me how to do it. I'm just going to name them, right? I'm just going to name them. As long as I give you one name, that's going to be perfectly fine. All right, so let's start with A. I've got the benzene ring. There's an OH group that's here, and there's a CH2, CH3 that's up here at the top. Oh, okay. I know what this is going to be. Look at this. This is a benzene with an OH. We know what that's called. We've already said that that structure is known as a phenol. Okay, well, how do I name the CH2, CH3? That is a ethyl group. So ethyl phenol is going to be the name. So if this is spot 1, because I've named it phenol, that means that my ethyl group is going to be spot number 2. So 2-ethyl phenol. Now, if I didn't want to use the 2, I could use the O, I could use the ortho, and that would also be correct. Whatever you like to use it, unless I tell you otherwise. All right, now let's take a look at B. I've got a benzene with a bromo and a chloro on it. They're both halogens. There's not really a common name for any one of those, right? We just named this like usual. So I'd follow the traditional IUPAC rules with these. All right, so what that means is that this benzene, I'm going to name as a benzene. The B comes before the C, so I'll write that one first. Bromo and chloro. And because B came first alphabetically, I'll give that spot 1, and this is spot 2, and this one is spot 3. So 1 bromo, 3 chloro, benzene. Next is C. Oh no. What do we have with C? Well, I see the C double bond OH group. Okay, well, that's an aldehyde. And if you go back and you take a look at those common names that I told you to keep in mind, you're going to be able to kill 2 birds with 1 stone yet again. We're going to be able to take care of the benzene and the C double bond OH group in one fell swoop, because I know from that list that this thing is called benzaldehyde, right? That's the one that they made the mistake on in the text, benzaldehyde. So if I call this benzaldehyde, that by default gives me spot 1 right there. Spot number 1. So this is spot number 2, and the bromo would be spot number 3. So this is a 3 bromo benzaldehyde. It's also a meta. For part B, that was also a meta. Now, let's take a look at part D. Part D, I see a CH2CH3, which is ethyl. I also see a CH3, which is methyl. So in order for me to name this, I put them in alphabetical order, and that's the one that I start with position 1. So this is going to be a 1-ethyl, a 2-methyl benzene. You might stop me and you might say, well, wait a minute. You told me that this benzene and a CH3 could be toluene. And I'm going to go, okay, yeah, you were paying attention. You can name this as a toluene. I'll count it right. If you name it as a toluene, it will be a 2-ethyl toluene, because that methyl group would get position 1 because you've named it as toluene. So if you want to name it that way, name it that way. Whatever floats your boat. I want you to be happy, and I'll give you a check mark as long as it's appropriate. All right, so in the next video, what we'll do is that we will review nomenclature again. So what you're seeing on the screen right now is an example problem. It says draw a structure for each of the following. So it's going to force us to go backward. Some people like these questions a little bit better. So M-chloromethylbenzene. How can I take that name and draw a structure from it? So right now, pause the video. Write down this example problem and try to answer these without looking at your notes or your text. Can you do it? Because if you can do this, then I think that you should feel pretty good about the lecture material at this point. And after the nomenclature issue is closed up, we'll then go into a little bit of reactions. And again, that's been the traditional template, right? Learn how to name them, learn how to do reactions. Learn to name, learn to react. Learn to name benzene, how to react with benzene. Learn to name substituted benzenes, how to react with substituted benzenes. And that's the template and the model that we're going to continue to follow. So here's the example. Hit the pause, write it down, try them, see what you come up with, and then in the next video, you'll check your answers with me, make sure they're okay, and then we'll keep moving on. Good luck.